Okay, here we have a stone of mass m being projected vertically upwards with a speed u, and we have the speed of the stone when it hits the ground, which is v. And we've been asked to calculate the magnitude of the change in momentum. Now, actually, I'll start here with the answer. The answer to this one is m times v plus u. But I want to talk very quickly about how we get this answer. A lot of students know this instinctively, but it's worth thinking about the physics here. When we want to calculate the change in momentum, then what we need to do is know the mass multiplied by the change in the velocity. And here I'm calling velocities v2 and v1. v1 is the initial and v2 is the final. And you'll see why I've done this just now. Now, in order to define velocities, we actually need to be a bit careful. We've got direction. Velocity is a vector quantity. So here what I'm going to say actually, it's a bit weird. I'm going to say that my v1 is equal to minus u, as in the initial velocity is minus u. And that's in here, basically what I'm saying is that upwards is negative. Now, that's not normally the case. Often we call downward negative, but it's okay. As long as I am consistent, then I can do this. What this means then is my final velocity is just v, positive v going down. Why are we doing this? Well, if we calculate our change in momentum now, we've got v, take away minus u, take away minus u, which gives me m times v plus u. And therefore, that's our answer C. Now, I could have done this the other way. I could have said that upwards was positive, downwards is negative, and I would have ended up with exactly the same thing, but with a minus sign in front of it. Notice the question is asking about the magnitude of the change in momentum, and so therefore the magnitude would just be ignoring that minus sign, and we get the same answer here. So that's why our answer is C.